Okay, so we're just going to finish up the notes from yesterday. And remember, we talked about the fact that everything is made up of atoms, even like the tip of this graphite pencil. The tip of it is graphite. It's made up of a series of carbon atoms. And then if we could zoom in, we would see the subatomic particles that make up the carbon atoms, like the protons, the neutrons, and the electrons. And what we're talking about is maybe observing some different phenomenon. Again, if we get the weather to clear up here and get a little bit drier, and if not, we'll watch videos of it, but some different phenomenon to observe what charges do. What? Just go ahead and say it. What? Yeah, hurry up. What charges do when they're like and when they're opposite, okay? The electrons and the protons. So we can see evidence that those charges exist when we look at the behavior of different objects during static electricity investigation. So yesterday, did we fill in all the charges on these different objects? Okay, remember that the only subatomic particle that can be transferred are the electrons. The protons can't be, okay? So if electrons move to an object, because the electrons are negative, that object will become negative. Hello? She is not. Okay. Bye-bye. And then remember that if an object loses electrons, it becomes positively charged. So let's go ahead and kind of finish off some of these different scenarios. So an atom has 100 electrons and 120 protons. So what that means is it has 100 negatives and 120 positives. Now remember, objects are made up of trillions of atoms and trillions upon trillions of subatomic particles. So we're just doing little example scenarios here. What would be the overall charge on this? What would it be, Brett?
Oh, positive because there's more protons than electrons.
Okay, good. Positive what?
Oh, positive protons.
Yep. Positive what though? 10, 20, 50?
Oh, positive 20. I'm sorry.
There you go. All right. So it would be positive 20. Now let me ask you a question. Alexis, is this positive 20 because it gained 20 protons, the substance, or did it lose 20 electrons? What did it do?
It lost 100 positive protons.
It didn't lose 100. It lost 20 what? Protons or electrons? Nope. Okay, so remember we talked about this. Proton number can never change, okay? The only number that can change is the electron number. If you gain electrons, you become negative. If you lose electrons, you become positive. So obviously this object started out neutral with 120 protons and 120 electrons, okay? If it now has 100 electrons, that means it lost 20 electrons, okay? Substances, because they hold on to their protons very tightly, are never going to lose or gain protons. But they do allow substances, their atoms allow electrons to be transferred. So those electrons can either be lost or gained. And in this case, we lost 20 negatives because we have a positive 20 charge. Okay. So a neutral object that loses 100 electrons to the ground, what would it become charged if you lost 100 electrons, Brett?
Positive.
Positive what?
100?
Yeah, positive 100, okay? So for our explanation, we'll just write positive 100 charge lost 100 electrons, okay? So again, we're just putting real numbers on this to kind of model what's happening, and we'll be doing things in different ways. Now, normally, typically, again, if we didn't have such high humidity today, I would do a little demonstration, and you can actually see evidence that I've done this in the past because I have a paper clip hanging from the ceiling up there, and I normally take a thread and I wrap a ping pong ball in aluminum foil, and then I suspend it and I take a balloon and rub it to my head to get electrons on the balloon then when I hold it near the foil ball, it attracts the foil ball because all the positives in the foil that make up the atoms are attracted to that excess negative charge on the balloon. And what ends up happening is it'll pull it close, and then if it touches, some of the negatives are transferred to the foil ball and some are still on the balloon, so then they actually will repel each other. Kind of a cool demonstration. I can't do it again because of the humidity, but that's what this is kind of showing you here. Not the exact same demonstration, but one to just illustrate how charges behave. Remember with this whole opposites attract and like repel. So this is a rod that we've rubbed either with a cloth or some material, and this is a foil covered ping pong ball. So let's look at the charges on both, okay? So Natalie, how many positive charges are on the rod?
4.
And then how many negatives?
8.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go ahead and draw that. So what would be the overall charge on that, Natalie?
4.
Yeah, what kind of 4? Positive or negative?
Negative.
Yeah, so there'd be a -4 charge on this. And then what about the foil covered ball, Natalie? We've got 3 positives and 1 negative. So what's the charge on that?
2 positive.
Yeah, it's a +2. So what this model is showing us is that because the rod and the ping pong ball have opposite charges, the two are going to attract each other. So that's what that diagram is trying to show. So the negative rod attracts the positive ping pong ball. I'm not going to spell that out. And I can just put on there that opposites attract. Okay? So what we're trying to do is we're trying to, and you're going to do this more tomorrow, we're going to observe different phenomenon, like I just talked to you about rubbing a balloon to my head and then seeing what happens with the foil ball. And we're going to observe that, and then we're going to try and model what's happening with the charges. Now remember, no charges can actually be transferred from one object to another unless they touch. Okay? All right, so can I flip the page?
Sure.
All righty. So on the next page, let's look here. Now, instead of writing out the charges, let's do this. Every time you see a positive and a negative, let's cancel them. So I'm going to actually, there's a positive and a negative, I'm going to cancel it. A positive and a negative, I'm going to cancel it right here and right here. So can we see what the charge is on that? What is the charge? What is it, Brett?
I got +4.
+4, okay? So instead of actually adding your integers, you can just kind of cross off whenever you see a positive and a negative because it'll cancel, and then you count up the number of unpaired charges, and that's what your charge is, okay? So in this next one, Caden, what do we have for a charge?
+2.
Good, +2. Okay, so we have a +2. So how about Delilah? What are these two objects doing then? Are they attracting or are they repelling? They are repelling. And why are they repelling? Do they have like charges or do they have opposite charges? Yeah, and like charges repel. Good job. So like charges, in this case, the like charges are positive, positive, positive on the rubber rod, positive on the foil covered ball. Okay, they repel. So girls, we're just finishing up the notes from yesterday if you want to get those out. And then in this last scenario, Luke, let's go ahead and see what the charge is on the rod. So go ahead and start canceling your positive, negative. What do you think? What's the charge on the rubber rod?
2 negative. Or 3. Yeah, 2 negative.
I don't know. When I did it, didn't they all cancel or no?
They all cancel out.
Do they all cancel out? Do
Yeah,
they?
I think he's talking, are you talking about the ball? Because the ball has negative too.
Yeah.
Yeah. What about the rod? Do those all cancel out? Did I do that right?
Yeah.
What I want you to do is I want you to add 2 extra negatives on there because that's not drawn correctly then. So let's add 2 extra negatives on there, and so our charge is a -2. Okay? Because if this were neutral, nothing would happen. All right? So this drawing would be incorrect if it were neutral. So now, what is the charge on this? Yeah.
-2 because the number of electrons is greater.
So that's drawn incorrectly, isn't it? So we need to fix it, okay? So let's go ahead and fix this one. I'm going to make this one neutral. And I'm going to show you how this works. Okay? So the foil covered ball, I'm going to make sure I have 3 positives and 3 negatives in there. And I'm going to say that it's got a 0 charge, it's neutral. It will still attract, okay? Am I breaking the law of opposites attract and like repel? No. What have I tried to show? Can you tell what I've tried to show on here? The opposites are attracting. Even though this is neutral, what will happen if you have a negatively charged object, okay, is that if the other object is neutral, all the positives will kind of be pulled to one side because remember, electrons are orbiting the nucleus in atoms and they can kind of be pushed to the opposite side. So what's happening is we get a negative rod attracts a neutral ball, but the ball experiences, and you're going to see this tomorrow, a separation of charge. So literally all the negatives are kind of pushed to one side. They're normally orbiting around the nucleus, but they kind of are pushed to the other side because those like charges will be repelled. The positives will be pulled towards the rod. So substances, if you have one object that's charged, like this rod, and the other one is neutral, you can still experience attraction because all of the opposite charges are kind of pulled to one side of the object and the like charges are repelled. Gavin?
It's a ball. What is the word after the ball?
Oh, it says negative rod attracts neutral ball, separation of charge.
I didn't see the separation.
Yeah, separation of charge is what I have on there. So even though my drawing isn't super good here, what I was trying to show is sometimes we can see on an object, even though it stays neutral, we get a separation of charge where the positives are pulled to another object that has a negative charge. Okay? So we can see that experience. Then what can happen is if this ball touches this rod, you can get a transfer of some of the charge. If they both become negatively charged after they attract and touch, they will then repel. Okay? And so hopefully, like I said, in the next couple of days, if our humidity breaks, we'll have an opportunity to go over that.